Hey everybody, quick tutorial on why do we need to actually use right triangle trigonometry. So it has neat relationships called sine, cosine, and tangent, but what's the actual application of it? Well, here we go. So let's say you have the right triangle right here, all right, with, and this right triangle is NOP, all right, with an acute angle of 83 degrees. Of course, it's a right angle, and you could actually calculate the other angle if you wanted to. If you really wished to do that, well, it looks like that would have to be 7 degrees, all right? Because 7 plus 83 gives me 90. 90 plus 90 is 180. So that's 7 degrees, just in case you want to know that, all right? And we're actually going to use it here in a second. So if I want to calculate the value of x, so I wrote down some steps right here. First, I want to think about, okay, which trig ratio, and I'm going to pick an angle, right? I'm going to pick the angle 80, the angle 83. What trig ratio could I set up using the sides that the triangle gives me? All right, so it looks like I'm looking for side x. Well, that side is opposite of 83 degrees. And it looks like I also have the hypotenuse. So I want to think, all right, so my acronym SOHCAHTOA. I want to think which of these three ratios that I studied and that I'm so skillful at identifying involves the opposite in the hypotenuse. Well, ding, 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 that would be the sine. So what I can say is, all right, so the sine of angle n, but instead of angle n, I'm going to give it the actual value. The sine of angle 83 is equal to the opposite side, which is x, divided by the hypotenuse, which measures 83. That's just a coincidence, all right? That has nothing to do with this 83-degree angle, all right? And it just so happens that here with Desmos, I can calculate what the sine of 83 actually is, all right? Because that is a known right triangle. All right triangles with an acute angle of 83 degrees will have that same proportion. Now, what I'm going to do right here is I am going to make sure that my calculator's in degree mode, all right? Radians are something that you will study later on in life. And it tells me the sine of 83 is 99%. In other words, this side x is going to be 99% of the length of the hypotenuse. All right. So I can, and careful with rounding. I'm going to round here for sake of showing you how the problem works. But actually, you know, when you get that decimal, you're going to have to multiply both sides by 83. So I'm going to go ahead and say, I'm going to take 83 times whatever decimal I get for sine of 83. And that should be my value x. See, I multiplied both sides by 83. Okay, so I'm going to go ahead and put that in my calculator. I'm going to go ahead and multiply that by 83 just so that I don't have to round. I know I said I'm going to round a second ago. Let's say 83 times the sine of 83. Remember the second 83 is degrees. All right, so it tells me that side should measure 82.38 units. All right, so that's 82.38. Okay, very good. Then one more way of solving the problem. So what if you wanted to use the 7-degree angle instead? All right, well, I can use side x and side 83, but from the vantage point of 7, that would be the adjacent side and the hypotenuse. So I can say the cosine of 7 degrees is equal to adjacent x divided by hypotenuse 83. And if I want to solve for that x, I'm going to end up multiplying 83 to both sides. So it's going to be 83 cosine of 7 degrees. All right. And if I come over here to my calculator, all right, 83 cosine of 7 gives me the same amount, the exact same amount. So that's 82.38 if I round it. All right. In other words, this side x is very close to the length of 83. And that's because we saw that the sine of 83 was approximately 99%. All right, so 82.38. We just showed how to do it two different ways. To summarize, you can choose your angle of reference. I started with the angle of 83 and used sine. I showed you a second way by using the angle of 7 degrees and using cosine. Set that problem up, multiply both sides by the denominator, and you will solve the problem.